Now we are going to do problem 43 from section 15 homework. Here we have a function f of xy, and we have a region that's just a circle and its interior, where the circle is centered at the origin and of radius 2. Now the teacher went ahead and already calculated what happens inside the circle, and he found there's two critical points, one at 0, 0, and one at minus 5, 4, 0. He also went ahead and calculated the values of the function f at those points. But what he didn't do, because he got lazy, was he didn't check what happened on the boundary. So the goal of this problem is to go ahead and completely solve for the absolute maximum and absolute minimum of f of xy on S by looking at what happens on the boundary. Notice that the problem is about the values for the absolute maximum and the absolute minimum, and not where the points actually are that give you those values. So what we need to do is to find a function that will represent f of xy on the boundary, and we use that on the boundary x squared plus y squared equals 4. So I want to replace the x squared plus y squared here with 4, because that's what it's equal to on the boundary. That gives me this function g of x, the 3x squared plus 9x now times 4 minus 4x cubed. I went ahead and expanded this, so I have the minus 4x cubed. I have a 12 from the 4 times 3x squared, and I have a 36x. We're adding those, and that is g of x. The other thing we want to keep in mind is that because we're in this circle, x is between minus 2 and 2. Now, we have a single variable problem of computing the maximum and minimum of g of x, a function of one variable, where x is between minus 2 and 2. So we go ahead and take the derivative of g. This is going to give us minus 12x squared plus 24x plus 36. And I factored out the minus 12, and I need to continue factoring. We can see this is x minus 3 times x plus 1. So we get g prime of x is minus 12 times x minus 3 times x plus 1. So there are two places where this is 0, at x equals 3 and at x equals negative 1. We do not want to look at x equals 3 because it is outside our region that we're interested in, where x is between minus 2 and 2. However, we do want to consider x equal to negative 1, since that is between minus 2 and 2. So we have 3 points to consider for x. One is the minus 2 and 2 that are the endpoints, and then the minus 1. So now we want to look at g of minus 2. We go ahead and plug that into here, the minus 2, and we get minus 8 times 8 is 32. And then 12 times 4 will be 48. So that gives me 80. When I multiply that, or add to that the negative 72 coming from here, that'll give me the 8. I plug in minus 1, I get 4 plus 12, so that's 16, minus 36, that's giving me the minus 20. I plug in 2, I get minus 32, plus 48, that's going to be 16, plus 72, that's going to give me the 88. So now we have the values we need to consider for the absolute max and absolute min. We have 0 up here inside the circle. We have a minus 625 over 256, which is going to be between minus 2 and minus 3. That's also occurring inside the circle. And then we have on the boundary the value of 8, minus 20, and 88 for our function f of xy. So the maximum of these is 88. The minimum is minus 20. And so we're able to say the global maximum on S is 88, and the global minimum